So, I just wanted to show, go over this program I made that, like, it was hard, I put work into it, and I feel just a little proud. Like, it's not even that good, but like, I kind of just want to show it. Let me like run it first, I guess. So, if we pull out the what's it called? This. I can't type. Holy shit! It's been a couple of days. Like, since I made it and I didn't comment the code, so we're gonna see how this goes. I can run it in Windows too. Um, but here it is. It's basically a calculator. I wonder if you can add a title for that for the thing. I know you can add icon, but I don't know about title. It's basically a calculator. Right, 27. It can handle the operation shown, not negation. It can do times it cannot do times negative one. It doesn't support like entering in negative numbers. Even in my README, which I have on that's on like GitHub or whatever, or where are you on this? I literally say like, oh hey, it doesn't work for anything. There's no floats, no integers. Basically, we have whole numbers, um, and that's it. Well, like for entering, right? But it can handle other things though. So it starts off with this my super main class. This is basically just your normal main class. The reason I made this is because I used Maven to make this, and I just don't think it in my experience of just this, it didn't like having my main.java as its own thing. So we just have super main.java that does nothing. What the fuck? Huh? Oh wait, right. Never mind. I couldn't fucking. Never mind. I don't know why I typed it like that. Like if I wouldn't even be able to read it, that's no reason to make that change. Yeah, right here. It literally just calls main and dot main. So simple enough, right? So now we're into the Java the UI part, right? I didn't separate it. If that's what you're supposed to do, oh well. Use Java FX for it. That was a process. So my original idea was to make like a calculator, like a literal calculator. Like I don't have my TI-84 on me, but that basically a scientific calculator, and I want to process to that. I want to get to that eventually, but not in like your normal conventional calculator. I might still add buttons and stuff. For example, if you want to add an integral, instead of having to type it in, I may make you like press it until I deal with trying to deal. Like maybe I can get some latex in there and then be able to evaluate that. Possibly, I don't know. Um, but so we have a public class main extends application, and we have two constant strings that get binded to some things, right? Those so the top one is the equation that's shown up top. So when I do 9 times 6, as I'm pretty sure it is, for example, the top one is the result, and the bottom one is going to be what we typed in. So we evaluate the typed in expression, right? So we have our main function, which really just launches args, right? So basically, the meats of the building stuff is right here. Uh, and the way I did it is we have functions to create things I'm using. So we have our scene. We attempt to get the CSS, which is how this thing is styled, cascading style sheets, right? Um, if it doesn't, then womp womp. I set so that this is a function. Oh, actually, did I change that? Ooh, I forgot to. I made a function just for this entire thing, just because it was like look how big it is, right? Um, but basically this allows me to just press enter instead of pressing submit. So I can just press submit it and like it'll go. But if you want to press enter, for example, if you're on a numpad and you're just typing quickly, then you might do that, you know? Then we just set our scene to set the scene and show it because primary stage is this. Um, it calls create content right here. This is the thing that's putting all our stuff together. So we have our text area, where we're putting our text and the results, both set to center alignment. So now we'll go just in order. So first we have create text field. This is what we're using to type in. So this box right here, that's our text field. If we look at the CSS, the text field, it's transparent, not a straight black background. The text is white, then just some other stuff, right? Um, and this is binding it to typing equation, which is what gets evaluated as shown, as said before, right? And prompt text is just literally telling you, hey, if there's something in here, then you gotta please enter it, right? So next up in there is create submit button, which is right here. Where are you? Where are you? Here it is. So here we go. So set equation right here. This is it for set equation. I could have probably split this up even more, but yeah. So it just makes the button, adds it to the CSS, and calls it on action of being pressed to do this entire thing. Which I'll explain that as we go, actually. From the so typing equation dot get, typing equations dot string, just getting that string. So first let's go ahead and look at the rest of these. So after that, that's our horizontal, and then we have a that's our H box, horizontal box. We have a vertical box, which is going to show our supported functions, the label, and our fuck is EQ label and text area. I don't even use text. Oh wait, oh text areas. Okay, okay, I'm stupid. Yeah, so this is what's showing this, right? And EQ label is binded to equation as known, and then create supported functions is really just something to show what functions are supported. Um, as of now, this is grouping slash multiplication because like you can do 5 times 6 like that, you'll get 30. It also works the other way around, so I can do this, and I'll get it. That was the thing, right? So that's basically it. So now we can come over to this part, which is calling the rest of this stuff. So we'll start from the inside out. We'll have tokenize type our typing equation. So if we go to tokenize right here, this is where we're making tokens out of our strings. So first of all, we have to define what tokens are. So I've made what our types of tokens are. We have a literal, which is just your numbers, an operator, which is current. I actually haven't put in factorial yet because I'm not sure how to do that, but it's just separated as an operator right now. Left bracket, right bracket, and I usually use space. Actually, I wonder how this handles. Actually, no. How it handles like extra stuff right now is that it's literally just zero as seen. Like we all know that's like the isn't zero. It's not. It doesn't return anything. But that's what I have it as in evaluate. If postfix.is blank return 0. And it does seem to just skip over those as well. So I have, yeah, but see, this, like, if there's no operator between, it just doesn't, like, get it, I don't think. See what I mean? But, like, I don't know how someone would deal with this, other than to say, hey, it doesn't work. But if I were to do, like, this, maybe? Huh, oh, wait. It still does. Oh wait, hold on. That's because that's not very. Okay, there we go. So yeah, it can evaluate when stuff's in between it. Um, where was I? Oh yes. So we have our token types. Operators brackets separated because they're found differently in our parser. Um, and then just saying how we can define these a function to say this is a token and a function for telling us what type of token it is. Which basically is saying, okay, token type contains whatever. This token type that this, because yeah. So we have our tokens here. A token is something that has a type and a value, and then we just have getters and setter functions and our toString. Right. So now we have tokenize, pretty big, right? This is just saying because it's used several times that we can set it into a variable that is squiggly. But I didn't do that because I found like when I tried it, I found problems and I didn't feel like fixing them, so I just have it as this long thing. Is it a good design? Probably not, but what would I know? Um, Starting from the top, so we're returning an array list of tokens, which is going to be evaluated by the parser. So we just create that array list, uh, and everything. But most of the things don't really have that many imports. I mean, like technically, I could have probably. I mean, technically, you could probably make your own array list too. But then I also have hash map and stack and parser and stack and evaluate too. Oh, I have list and stack and array list. Why do I have list? Who knows? I don't remember. Oh, 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 that's just in case people are whatever. So, So now we iterate through our token, which is a string, right? Token length minus one, iterating through it. Um, and huh, okay. So we start off with saying if it's a space, we just skip it. Simple enough, right? So next up, it's saying if it's a literal, right? Hold on, let's see. If I is not zero, and we have a literal right behind, if we have a literal right behind something, and the current thing is a literal, we skip it. This is because our next thing, if token type is literal, then we're gonna go ahead and make a thing, right? So first we're gonna say, okay, we're making a new token, um, and we're gonna have our type literal and the string that value of the character because that's how I'm iterating through a string. I could have maybe had them support maybe turn it into a list spread out fully, and then in that case I'm doing dot split. Then it's gonna be I don't have to deal with spaces in that way. I don't think. Right? And then we also define a j int j here. This is in order to check the future things. So it's saying while j is less than or equal to token minus one. So basically, while it's less than our total length, um, and j is starting one after our current I. So let's say we have our array or string of 10 characters, and I is currently 2. Then j is going to go 3 to 9. Yeah. Index 3, which is going to be the fourth character, and 9 is the 10th character, because indexing is 0 to 10 in Java. It's most languages, to my knowledge. Not all of them, though. And then it's also saying, okay, and while the next one is also a literal, we're going to go ahead and set our value to be the current value, which was made, right? Because we made x, and then we also are adding that string onto there. And then we add j, we make j increased. And then after that, we check if j is greater than the whole string, because just in case, like we get to the end, we check it, and if it's too big, then it's gonna break, right? So after this, then we go ahead and add this to our relative tokens, right? So next up is just checking if it's an operator. Simple enough. Currently, I was thinking about because I was trying to figure out how to implement like negative numbers into this and supporting that, and so I had that in operator. It didn't work out, so I just went back. Um, Next up, we have left bracket. So it basically checks if the thing preceding it is going to be a. I wonder actually if we check this. So this should print out 49. Okay, so it doesn't work. So this part doesn't work either. Because this is the correct result, but huh. So maybe I should actually make a function saying if it's not something that's in my enum, we skip it or we delete. Hmm. Actually, a function of arrays is that if you're to delete something from their I, then that's going to like move the entire thing around. That's why you're supposed to be using iterators. But like we could actually abuse that potentially to so that we delete that, everything gets. I wonder if it gets shifted this way or that way. Regardless, it would be. I think I might be able to check the parentheses before that. I think so at least. Um, yeah, but yeah, it basically makes basically makes the operator such that it's gonna have a thing before it, before the bracket. Similarly here, except that it's a bit different. It's gonna check the thing after it, and then it's gonna insert bracket operator. Because if you did the other way around, then it's like, well, what are you doing, right? We keep this in here for when actually parsing, right? And then yeah, so that's tokenized. So after that, after we tokenize something, we have to parse it, right? So this uses the shunting yard algorithm, which is an algorithm made to parse mathematical expressions. It can do more than this. Like if you're a I don't know, calc student, you might have found integral calculator or derivative calculator. I got the inspiration to use shunting yard algorithm from those. And that gets to integrals and other stuff I can't do. Eventually, I want this to be able to do it though, right? So the shunting yard algorithm, we start off by making a string builder, which is going to be the just a string that I'm going to be returning, and then we have a stack. A stack is a last in first out data structure. I usually thought of it as first and last out, but they're both technically correct, I'm pretty sure. With two operations, push and pop. Well, I guess you also have peek. Push is going to go ahead and add something to the top of that stack. Pop is going to go ahead to remove it and return it. And peek is just not, it's not going to remove it, and it's just going to return it. Like you can literally see what it is, right? And so peek is abused here. All three of those are used here, right? So we're gonna iterate through our array list of tokens. Oh, I should have also said, right? So this is gonna be for our precedence to deal with order of operations. PEMDAS or BUDMAS, just so you know, it's parentheses, exponents, multiplication, division are equal. That's why these two are here. And then addition, subtraction are equal. It does left to right. Fuck. Um, for stupid Instagram niggas. Anyways, um, so we're iterating through the array list of tokens. We're making a token, and we're calling a token. We're just literally getting it from there. Then we say, okay, if it's a literal, we're just gonna put it on the string builder. If it's an operator, if our stack is empty, is not empty, and we check, and the precedence is gonna be what's it called, greater than our current token, then we pop that in the stack, and then we insert this either way into the stack. And this is going to keep going on until the end, right? So if it's a left bracket, we just push it into the stack. If it's a right bracket, because remember, we always want something to be paired. Fun fact, this doesn't work. I haven't implemented error check or anything like that, because obviously. So if I do something like this, terminal, we get errors galore. So yeah, a lot of them. Have to spend years scoping through it. That's because I pressed it multiple times. It doesn't actually crash, to my knowledge, so it just returns the error in there and doesn't work correctly. Which I mean, it's probably a plus. That means I didn't do something so wrong that the entire thing would just break on me. So that's a W. For our right bracket, it's gonna look at our stack, and if it's not a left bracket, it's gonna go ahead and pop it, and it's not empty. It's gonna pop into the output, popping, pushing, removing it, and then returning it, pending that. Then if stack is gonna be, and if it's stack is left, then we just pop the left. We don't put it in there. Then if the stack is empty, we just pop everything else out. And this gives us postfix notation, which is what we use to evaluate. So we have our evaluate here. This is also making a stack. This is evaluating postfix, which is what we get it. Postfix is like an alternative way to like read things and shit like that. I'm not 100% sure. Well, yeah, what's given is an infix, to my knowledge. Infix, prefix. I don't fucking know. Infix, I think. It's an infix, right? So first, we have a string called postfix. We're returning a double because, yeah, if it's blank, then we just put zero. Like, yeah, um, because nothing that's like a letter or anything that's not in the token types isn't gonna end up over here. Yeah. We make output, which is literally just saying, which literally just gets made into it right here. We're iterating through look through, which is an array list, which is splitting up postfix. We could have probably just made this into a list from parser, but whatever. Make it bigger. Bigger is better, don't they say? Not always, whatever. Um, so we say if this is a literal, and we're just saying right here that we're gonna push it into the stack. If it's not, then this is where we're evaluating stuff, right? So we call A and B, which is gonna be the two things, right? Um, just fundamentally we have A plus B, A minus B, everything like that, you know. So obviously this doesn't deal with single operator things. Like if I implement factorial here, it's not gonna do A and B. It'd be A and B's evaluated first because you'd probably it probably automatically put parentheses around them, which I don't know. I don't know how I would even get parentheses around that, honestly. Um, anyways, it deals with that, and then we just say, okay, we're gonna push to the stack, um, these, yeah, yeah, we're adding to the stack, each of these, and I have normal function, which is where I'm gonna putting a bunch of math stuff. I have a different package for it, DZ math. Um, so like when I get other stuff in here, it's gonna be there. But right now, it's just a function to take the power of something. So if it's zero, if b is zero, because anything to zero power is one, or a is one because one of the one, any power is one, then you return one. If b is less than zero, I wanted to do that, but I don't think it does. Uh, maybe it does. It does! Okay. But that's only for negative numbers, so that's just making a fraction of it. So yeah, 6 to the negative 1, negative first, 1 over 6. Cool. Can't handle square roots though. Um, so like if I were to do this, it doesn't know what to do. Yeah, and then where we're here. Then we just have output equals double dot parse stack dot pop. And remember, these things get pushed, and it's taking from each of these and then putting them in a stack or something like that. Yeah. And then we just return output, and then that's all of those are like called into one right here. Yeah. So we have value, parser dot shunting yard, tokenize dot tokenize, typing equation dot get, string dot value of that because we're returning a double, and the equation is a string. So yeah, and then that just gets sent in there, and we end up with this. So yeah. Thank you. It was really painful. And this wasn't even the most painful part. The most painful part was dealing with because I made module.java because I wanted to like get it. So like you can run this on Windows. This is currently on Linux, but like in my GitHub, the Windows version is what's there. And the pom.xml. I don't even know. I still don't even understand this low key. Like I think I spent more time trying to figure out the POM shit, especially on module info. Because like when I was trying to package it and I was like doing, oh, what the hell is J-Link? A shadow jar? What the fuck is that? Fat jar, skinny jar? I don't fucking know. But yeah, I enjoyed making this. I want to make it bigger in the future. Make it more usable. You know, make it support many more operations. Maybe I can get it to compute really big numbers or something faster. Give me some like tetration or something. I don't fucking know. I think it really gets too big too fast to reasonably calculate with numbers in the universe or whatever. But whatever. Thank you for watching. If you somehow made it this far, I don't know, I'll give you a head or something. Bye.